Okay, we're moving to, I think, our last example, and it is a graph of a cyclist. And you understand that cyclist has a rhythm that they gauge in order to get the maximum speed. And it's not going to be the same speed all the way across. We have a almost professional runner as a colleague. Her name is Gail Illage, and she's a runner, and she carries a timer to make sure that she's running like she planned to run on those marathons, because a marathon is not the beginning, it's the end. And she does very well. And she uses that in her statistics to show all of the changes that happen in a running pattern and the rhythm necessary to complete the task. So this is a cyclist, and they want to know what is the average speed. Now remember, we're looking for keywords. Average speed between the interval, sorry about that, the interval 0 and 1. So here we go. So our first step is to find 0, 0 is the start to 1. And in 1 we approximate 8. Does everybody agree about that? All right. So we have both conditions. So we want average. And that means that I would have the end point 8 minus a 0 over 1 minus a 0, and we get 8. And this is per hour, and it's miles. All right. Again, when you do the homework, you just expand it and get the best guess. Some of them you do kind of estimate. What is the average speed in miles per hour over the time interval 1 to 2.5? Here we go. Okay. We know what 1 is. 1 is 1 and 8. Now we need 2.5. So I'm going to, oh, it came out good, 16. Right? So again, we're going to do the change of y over the change of x, and that's going to give me 16 minus 8 over 2.5 minus the 1. All right, so we'd have to do the calculator or multiply it out or divide it out. I'm going to use a calculator. I bet your math is awesome. Okay. Ooh, sorry about that. Oh, I added it to something. I was doing a problem. Oh. While you all were taking a break, I was trying to finish. And I get, yeah, approximately 5.3. All right. Now, we notice that between the one and the 2, we're doing a speed increase to get to this leveled off spot. But it slowed him down, didn't it? Because he reached a plateau. At 2.5, he reached a plateau, which means no change of speed in that. So it became less. Crazy, right? Okay, then the speed from 2.5, which we already know, 16, and 3.5. So 3.5 is here, and that is 20. So again, we're going to do the little math, nothing serious. And this gives me a 20 minus a 16 over 3.5 minus 2.5. So this is 4. What's he doing? Yeah, a little bit. Catching a breath. Hard here. And then he reached them kind of, I don't know the terrain either. So, which of the following is a cyclist's instantaneous rate at t is 1/2? So t is 1/2 is right here, and we want the change of what happens there. And so you're looking at this point change to this point change. So it would be a half of that 1, wouldn't it, pretty much? And that was 8. So what would we say? Well, it is still 8 miles per hour because he was going at that rate at that time. Everybody comfortable with that? All right. That's great. That finishes 2.1, and we're going to go next to 2.2. Thank you for listening.